welcome to this next video. In this video we are going to see question of June 2019, that is a very recent question which is of 4.5 marks, 4.75 marks. So let us see at the question. In the question they are asking, if you have the functional g of y as integration from 0 to 1 y dash square plus y dash cube dx subject to the conditions y of 0 is 1 and y of 1 is 2. So in this question you are given fixed boundaries, fixed boundary conditions are given. Moreover, the functional is of the simplest form. Then we need to suggest that the extremal belongs to which of these four classes. So let us get started. This is a very simple question. So let us first write the Euler's Lagrange equation. What is that? That is f of y minus d dx of f of y dash is equal to 0. So f of y is 0 in this case, minus d dx of f of y dash, that would be 2y dash plus 3y dash equals 0. So in this case we have 5y dash is equal to constant. So let me call this constant as c, right? So I can write it as y dash is equal to d, where what is this d? D is c by 5, right? So let me integrate this once more. So I would have y is equal to dx plus e. So this is the given extremal. Now let us find what this d and e are from the given boundary conditions. So I am using this boundary condition y at 0 is equal to 1. So this gives me 1 equals e is 1. And another boundary condition which is y at 1 is 2. So this gives me 2 equals x plus 1. So sorry, x, not x, it's d plus 1. So d would again be 1. So in this case, what is my y? Therefore y is x plus 1, right? This is my y, this is a polynomial, and you can and to see what class it belongs to, you have to clearly you can see that this is a continuous function. Let us take its derivative, first derivative. What would be that? It would be just 1. So it is also continuous, being a constant function. Let's take the second derivative. So y double dash would be 0. So it is also continuous, and if you take the nth derivative, then they would again be 0 only. So they are also continuous. So what is this class? The class C1 from the interval AB is the class of functions whose first derivatives are continuously differentiable. Whose first derivatives are continuous, right? C2 in the interval A to B is a class of functions where the second derivatives are continuous. Up to second derivatives are continuous. So and similarly in this way we can write it as C infinity AB. This is a class of functions where every derivative up to infinity of the given function is continuous. So looking at this, let us see this in this way, that suppose this is some class C1 class where all the first derivatives are continuous, right? Let me draw another class. Here this is C2 class because in this class, this whole class, you can say that all the first and second derivatives are continuous. So obviously C2AB would contain C1AB, and similarly C3 class would contain C2 class. So on, if we keep on extended like this, so we have some class called C infinity class, so that C infinity class AB contains all other classes. So this might be clear to you, right? So if we look at the notations, what does this notation means? It means that y belongs to the class C1, but y does not belongs to the class C2, right? Y belongs to the class C1 but does not belongs to the class C2. Similarly, y belongs to the class C. Class C means all the functions which are continuous, and does not belongs to class C1. Here y belongs to class C1 and here y belongs to class C2, right? So our answer is y is equal to x1. So we clearly saw that y belongs to C infinity class on the interval 0 to 1. So obviously y belongs to C1 class and C2 class. Here you are saying it belongs to C1 class and does not belongs to C2 class, which is not true, because here it belongs to C infinity class. That means it belongs to all the C classes, right? Yeah. So this option is wrong, this option is wrong, this is the correct option, this is the correct option. So the correct options are C and D. Thanks for watching the video. Please like, subscribe and share to this channel. Thanks.